Good morning, good afternoon, and good evening, philosophers. Welcome back to Philosophy of Science through the lens of medicine. Last time we looked at a bunch of attempted solutions to Hume's problem of induction, but ultimately found that whilst we could improve the recipe for scientific practice, we simply can't logically guarantee that the future will resemble the past. So what do? Enter Karl Popper, who looks at the problem of induction and says, fine, let's not use induction as the foundation of science. It's the philosophical equivalent of seeing a locked door and climbing through the window. Popper's key move is simple but powerful. There is a logical asymmetry between proving a theory true and proving it false. Take the classic example that all swans are white. How many white swans must you observe to prove this true? 100, 1,000,000, every swan in Johannesburg, London, the entire wetland community? Still not enough. The next swan could still ruin your entire career. But how many black swans does it take to refute the claim? That is, to prove the claim false? 1. A single black swan does more logical work than a stadium full of white ones. This is Popper's big insight. Universal scientific claims can't be conclusively verified by piling up positive examples, but they can sometimes be falsified by a single counterexample. So, Popper says, stop pretending science proves theories true. Science works by proposing bold conjectures and then trying very hard to kill them. A scientist is not someone who says, please admire my theory. A scientist says, here is my theory, here is exactly how it could fail. Bring snacks. For Popper, science begins with a bold guess, a conjecture. Then we deduce testable predictions from it, not vague predictions, not something meaningful will happen during Mercury retrograde, proper predictions, risky predictions, predictions that could embarrass the theory in public. Einstein's general relativity impressed Popper because it predicted something surprising. Light should bend near the sun. Mendeleev's periodic table impressed philosophers of science because it left gaps for elements not yet discovered. These were not theories hiding in the bushes, they stepped into the ring. If a theory fails the test, throw it out or revise it honestly. If it survives, don't say that it's proven. Popper says we should call it corroborated, not verified. Corroborated means this theory has survived serious attempts to refute it. It doesn't mean immortal, it means currently undefeated. Think of a scientific theory as a boxer. Corroboration is not a halo, it's a decent fight record. Now, where do scientific theories come from? Here, Popper is refreshingly relaxed. Bacon thought science should begin with careful, unbiased observation, as if facts would politely arrange themselves into theories if we stared at them long enough. Popper says, no, theory making is a creative endeavor. It's messy, it's human. A theory might come from a dream, a metaphor, a mistake, a religious idea, a mathematical hunch, or a caffeine-fueled panic at 2 a.m. before a grant deadline. And that's fine. Popper distinguishes between the context of discovery and the context of justification. The context of discovery is how you got the idea. Philosophy of science doesn't need to police that. The context of justification is how the idea is tested. That is where science begins sharpening the knives. A brilliant theory from a dream still has to survive the lab. A boring theory from the committee still has to survive the lab. Science doesn't care about your origin story. It cares about your exposure to evidence. This brings us to Popper's famous demarcation problem. How do we distinguish science from pseudoscience? Again, something that we looked at from Bacon's perspective in a previous video. For Popper, a theory is scientific only if it is falsifiable. That means it must rule something out. It must forbid certain observations. It must be possible for the world to say, nope. That is why vague theories are so slippery. If your theory can explain absolutely everything, it may actually explain absolutely nothing. Consider astrology. You may face challenges, but discover hidden strengths. That's not a prediction, that's a motivational mug with planets. Popper made similar criticisms of some forms of psychoanalysis, and some ways Marxism was defended. His point wasn't simply, these are false. It was that their supporters sometimes treated every possible outcome as confirmation. If the patient behaves aggressively, the theory explains it. If the patient behaves kindly, the theory explains that too. If workers revolt, the theory wins. If workers do not revolt, the theory also wins. That's not science. That's a theory wearing a bulletproof vest. Now, let's bring this into medicine. Suppose someone claims this treatment reduces migraine frequency better than a placebo over 12 weeks. Good. That's falsifiable. We can run a controlled trial, we can compare groups, the claim might win, lose, or require refinement. But suppose someone says this treatment restores an invisible balance in a way that no possible measurement, symptom report, or clinical result could ever challenge. That may be meaningful to someone, it may be part of a worldview, but it's not a scientific claim in Popper's sense. Acupuncture is a great Popperian claim because it's not one claim. It's a bundle of claims, some testable and some slippery. Let's start with the testable version. Acupuncture reduces chronic lower back pain better than placebo or usual care. This is a scientific claim. We can test it. We can run trials, observational studies, sort of randomized controlled trials. We can compare real acupuncture with sham acupuncture, usual care or no treatment. We can measure pain scores, mobility, medication use, and quality of life. The results may be impressive or modest or mixed or disappointing, but the key Popperian point is this. The claim is exposed to possible failure. It walks into the lab without a bodyguard. Now compare that with a stronger traditional interpretation. Acupuncture works by unblocking qi flowing through invisible meridian lines. Is it qi or ji? I'm not sure. Spelt QI anyway. Here's what we need to ask. What would count against that? How would we falsify it? If the patient improves, the meridians were balanced. If the patient does not improve, perhaps the qi was stubborn, the practitioner chose the wrong point, the patient's lifestyle interfered, or the blockage is deeper than expected. At that point, the theory becomes very difficult to pin down. It's less like a scientific hypothesis and more like trying to arrest smoke. So Popper's lesson is not acupuncture is scientific or acupuncture is nonsense. That's too blunt. The better Popperian lesson is, which acupuncture claim are we talking about? Clinical claims about pain relief can be scientific because they can be tested. Claims about invisible meridian energy become scientific only if they generate clear, risky predictions. Without that, they may be culturally meaningful, historically important, or personally compelling, but they're not doing scientific work. Science asks acupuncture the same rude question it asks everyone else. What would prove you wrong? Now for the twist. Popper makes falsification sound clean. Theory predicts X, X does not happen, theory is dead. Lovely. Unfortunately, real science is less like a courtroom confession and more like group work. When a prediction fails, what exactly failed? The theory, the measuring instrument, the sample size, the statistical model, the background assumptions, the lab technician who last slept properly in 2019. This is the Duhem problem. Scientific theories aren't tested in isolation. They're tested along with auxiliary assumptions, assumptions about equipment, measurement, background theory, initial conditions, and experimental design. Think of a clinical trial. If a drug fails, perhaps the drug is useless, or perhaps the dose was wrong, or the trial was underpowered, or the patients were too heterogeneous, or the outcome measure was badly chosen. A failed test does not automatically tell you where the failure lies. This is why falsification is rarely an instant knockout. It's more often a committee meeting with graphs. Popper knew this was a problem. His solution was to say that scientists must agree, at least provisionally, on which observations and tests count. But that already shows that the science is not pure logic on wheels. It requires judgment. Popper gives us something essential, but not everything. He's right that good science needs risk. A theory that cannot possibly lose is not doing scientific work. He's right that we should value bold predictions, precision, and honesty about failure. He's right that scientists shouldn't merely collect confirmations like Instagram likes. But Popper goes too far if he thinks science can avoid induction completely. Much of science is probabilistic. A treatment may reduce the risk of stroke by 20%. One patient having a stroke doesn't falsify that. Science also makes existential claims about viruses, DNA, black holes, and failing to find something once doesn't prove it doesn't exist. And historically, scientists don't abandon a successful theory at the first anomaly, nor should they. When Uranus didn't move exactly as Newtonian theory predicted, scientists didn't immediately throw Newton in the bin. They proposed another planet. That prediction led to Neptune. That was not a cheap excuse. It increased empirical content. It gave the theory a new way to be tested. Bad theory saving says, my theory is right, no evidence can touch it. Good theory saving says, here's a new prediction, go check. That's the difference between science and intellectual bubble wrap. So, did Popper solve the problem of induction? Well, certainly not completely. He avoided it brilliantly, but induction sneaks in back through the side door wearing sunglasses. Still, Popper did give us one of the greatest slogans in philosophy of science. Don't ask whether your theory can explain everything, ask what it forbids. A scientific theory must take risks. It must face reality without a lawyer. It must be able to lose. So, whether you are in a lab, a clinic, a policy meeting, or a lecture hall at UJ, remember this. Evidence is not there to flatter your theory. Evidence is there to stress test it. Next time, we look at medical conspiracy theories and traditional African medicine through the lens of falsificationism. Until then, stay critical, test bravely, and beware of any theory that always lands on its feet. Thanks for watching, and I'll see you on the next one.